welcome back to part 3. Time for some actual electrical content, eh? Welcome, this is part 3 of the motors and controls, starting motor control gear, direct online starting. So far,
previously on actual electrical content.
I'm in my garage, need something up. Hey, cocksucker. We've made a doll. This is powered up now, and if you watch this, look, I can press start. I can't, it's already started. Well, what the fuck's gone wrong there? Oh, it's tripped, look. It won't start the control circuit because it's tripped. That's a feature, not a bug. So if I reset that overload so that power would get through, and I press start, that contact's just pulled in. And when I press stop, that contact's just fell out. And that is exactly what I want to do. Say it was filling a bouncy castle up with this, say it was doing a blower, like your mum. I'd come along, put my blower next to my bouncy castle, plug it in, press start, and it would start, and it would continue to run. So I wanted to stand there with my finger on the button. If the motor tripped, it wipes out the control circuit, I can see the motor's tripped, and I can stop it. So now, we've got multiple layers on this control circuit, because there's multiple things going off. One thing is, I've got a 3-phase motor, and if we look on this closely in a second, I'll show you where the 3-phase goes in, through the overload, through the contactor, and out to the motor. I'm going to put a drawing up here if this is on YouTube. There's your basic control circuit, there's your basic power circuit, yeah? The motor supply comes in, it goes through the protection, goes through the control, then goes to the load and runs the motor. That layer exists here, yeah? There's just a layer of 415. On top of that, in the last video, we put the control in so we can start it, we can stop it, and when it's started and the overload trips, it wipes out the control circuit because that's what we want to do. Because we don't want the contact to stay in when the overload's tripped and the motor can't run. That is another layer. So now you've got your 415 layer and your control layer on top of it. So on those layers, the 415 layer, which sits here, has the control circuit on top of it that enables the start, the stop, and when it trips to turn it off. Those layers are electrically separate. They don't interact between each other. However, when they get inside components like the contactor, they get mechanically connected up. And that's what we're talking about. The 415 layer, the 24 volt layer, which is the control, don't come into contact apart from mechanical actuations making them do things in between. And this works. Like I say, if you go to the bouncy castle, plug it in, press start, it's tripped, press start, and off your pump goes and blows your bouncy castle up and you're away. So if you was doing this, it'd be fine. You'd know if it was tripped because your bouncy castle would start deflating and you'd be well away. I don't know why I picked a bouncy castle, but there's more than one application for a motor. So let's set in a scenario for this motor control system that's a little bit different. Here's what we're going to do next. We're going to utilise this for a pump. And the pump is in a lake. And the lake is going to be a mile away. So a mile away in a direction from where you are sat now, there is a lake. And in that lake, there is a submersible pump. A cable comes from that pump and comes into a shed. And in that shed is your motor control gear and your supply. So the contactor and the overload are in a shed with a supply from a fuse board. Then the cables go a mile and they go to a pump. That's the scenario we're going to have. Maybe I'll interject here with a picture of it if it's on YouTube, but I'm not going to in this one, so I can't be asked to move the camera to the whiteboard. But that's the crack. Same thing applies. If I walk along here and press the start button, now we assume that power is going to the pump and the pump is running. However, we don't know. We don't actually know if the pump's running because of a few reasons which I'll go into now. As I said, the pump's about a mile away. So when I press start, if the pump does start running because the electric goes to it and the pump ends up here in a tank, I don't know if the pump's running because the pump's a mile away. I can't hear it. I also can't see it because it doesn't have anything to see anyway. And if the pipe was a mile long, then it'd take a few minutes for the water to get down the pipe to me. So I've got to basically sit here now, looking at the end of the pipe, or if I can even see the other end of the pipe, hoping that some water pours out. Maybe it will, maybe it won't. But I've got to sit here and wait because this contactor is not here. I can't see it. That could be in the room next door. And this push button station that I'm controlling it from might have been a separate building. So let's pretend the pump's a mile away in that way, the little shed's got the contact and the overload in, but this start-stop system is somewhere on your site where the water comes out. Well, now, I don't know what the fuck's going on because I've pressed the button and nothing's happening. Now, the thing to remember now is I'm a human controlling it. So when I press start, all I've got is, well, I ain't got anything. I can't hear the contact, I can't hear the water. Eventually water might come out, but I've got no visual indication. As a human, I need a visual indication that something is probably running more light than it is now. I've got nothing to look at. And if it was a computer like a PLC, I'd still want some indication, maybe a PLC starting it. And now we're in a whole new realm. So we've got us 415 volt level. Yeah, we've got us control level. But now we're going to add another level, which is the indication. Because at the minute, I haven't got a fucking clue what's going off. If I'm a human, I'm going to use these lamps to give me indication. But these lamps just take a 24 volt supply from a normally closed or normally open piece of control gear on here. So what the important piece to remember is, as a human, I look at the lamp. But if I was a computer, I'd look at the voltage. So a human looks at a visual thing like a lamp or a HMI screen or some sort of computer screen, whereas the computer just looks at a voltage that's going off. But they're both the same. They still derive from a normally open or a normally closed contact. So let's flip you around now, and I'll show you on here how we can add some of those features in so that we get more indication that gives us a better idea if something's running or not running. So this is we've had the 415, we've had the control, now we're going to do an indication layer to either humans or computers, or maybe even a mixture of both. The world really is your oyster with controls. You can do the visual indication on the lamps for me, and the computer indication for the PLC, whatever. It's a very simple example, but what you can actually achieve with all the normally open and normally closed is extensive. Right, let's just get this straight. This is the push button station with the lamps on. That could be anywhere else. That's the contact on the overload. That could be anywhere else. The pump is a mile away, as we've discussed. So we're not, although we're working with it all in a row here because it's easier for filming, these could be in separate locations. If you look down here, the white wires simulate the mains voltage. The supply even, comes in here and goes into the overload. Goes through the overload if it's alpha, comes out of here. Goes all the way around into the contactor and out the contactor to the motor. I will put a drawing of that up next if this is on YouTube, and you can have a look at that. That's the 415 circuit completed. We was already there from the previous videos. Then, currently, we've got a basic doll starter. So they've got a 24 volt power supply coming into here, which is a control voltage. It then goes around through the stop, through the overload and that. So basically at the minute, if we press stop, the contactor stops and the contact falls out. So it's in its not working state at the minute. We press start, the contact pulls in, lets the voltage through, as long as the overload isn't tripped, which would cause the control circuit to turn off. But we're healthy, as overload's good, we can press start and we can press stop. That's where we're at. Now let's look at adding some layers of control to this so that we can see, or the PLC can see things, and it's not as hard as it sounds. It's just simply normally open and normally closed contacts. That's all we're dealing with, and that's the bit you need to get into your noggins. One of the things you need to remember when you're adding in indications is where you feed them from. Because there's no point feeding the power lamp from the wrong side of the contactor, because it won't work. Let me demonstrate that. Let me pull out this white lamp and let's use that for the first thing we're going to do. So all these lamps are just wired to cables. This one's wired to here, look, it just says white pos. So if I put that to a voltage, which is down here, you'll see the white lamp light up. Just coming on and indicating that there's voltage. So what I'm going to do is, from a main voltage down here, which is this little connector block, I'm just going to place it in there. And that is our first indication. So now, when you walk up to the push button station, the first indication you got is that the power is on. Yeah, the control voltage is live. Not the mains voltage, the control voltage. The problem is, if this trips, oh no, it does work, I've wired it right, I've wired it from the right side. So that now indicates that it is healthy and powered. And if there was a trip, it'll go off. I don't want it to work like that though. I want it to be on all the time. So I want that to be on to indicate this power, not indicate that the system's healthy. So I'll rewire that now. And that's why it's important where you take your feed from. So I had to take my feed from somewhere else now, not there. So the first place I took my 24 volt feed was to this point here. So I'm going to place this white cable in there because that's the first point where my 24 volt feed comes from. So now my lamp should come on, which it has done, or will do when I've got this terminal in. And now that is indicating the presence of a 24 volt supply voltage. And when I press this off now, that stays on. Although it's tripped, I still have 24 volt supply voltage. That's very important because I don't want the trip to take out my lamp, because at the minute, me or my PLC would know my voltage is healthy, but something else is wrong based on other indicators. So, like I say, it's really important where you take your feeds from. So in this case, I want my lamp to say the control voltage is healthy, and so far, it is saying the control voltage is healthy. But if this trips, we don't know, do we? So we need another way of doing that. Let's have a look at that. So the next thing I want to do, now I know we've got a healthy 24 volts light, is I do want to know if this is tripped. Well, I've not got anywhere to find now. So now I'm going to take the amber light, which is here, just check it on the voltage. Yeah. And I'm going to put this into a switch that tells me that it's tripped. Well, on my switch over here, on my auxiliary, on my overload auxiliaries, I've got a spare set of contacts here. So I'm going to put it in there. Let me do that off camera and show you a bit closer. So I've placed that amber into this contact here. So now when this switches, it will switch that auxiliary and bring my lamp on, won't it? No, it won't, because there's no feed to it. So now we need to give it a feed so that it will bring this on when it's off. And again, it's important where we take the feed from. So we need to take the feed from the permanent 24 volts. So no matter what happens, this indicates to that lamp. So let's do that. So we'll take a feed out of this main feed here into that, because every switch that you're using for indication requires to be fed so that it will light the indicator. There's no voltage there for it to light, so let's put that in. Right then, now I've got a 24 volt feed feeding that lamp, and I've got a 24 volt feed linked over to this other auxiliary switch, so that when I switch this, the amber light should come on. So at the minute it's on, indicating it's healthy, but when you trip it, that amber light's come on. So now as a user or a computer, I can walk over and look at this box and say, well, I've got a 24 volt healthy supply, so my control system is healthy, but I've got an amber light on indicating I've got a trip. So I can go and reset my trip. And when I reset my trip, my amber light goes off. So already, just with a few simple additions of 24 volt to some lights or some relays, I can tell the status of my control system on this separate layer we've put in, because there's the mains layers, there's the control layer, and this is the indication layer. So now, when I start it, I feel better already because I know it's healthy. But I didn't hear that donk because it's miles away. So now we need to know if the contact's pulled in. Let's add that in. Now, I want to use the lamps to indicate the status of the contactor. Or, not the lamps, a PLC. So I'm going to use a green light for running. That's green. Green is for go. So I come to a contactor, and when this pulls in mechanically, I wanted a way of knowing that. Now, on this contactor at the minute, I've run out of normally open, normally closed to use. But I can have one of these. This is called an auxiliary block. And if you look on the back, there's a little hook that hooks into the contactor. And as the contactor pulls in, it pulls these switches down and activates them. And if we look on the front of it, it's got a normally open that goes through there, a normally closed that goes through there, a normally open goes through there, and a normally open again that goes through there. So this particular one's got 3 normally opens and 1 normally closed. You can get these in different arrangements. And all I do is, to get these contacts to work with my contactor, is when it's in the off position, I slide this on. If you look at that little blue dot there, when I start it, it'll pull down. There you go. So now, I've got additional auxiliary switches. These switches are not capable of switching motors or capable of switching high power applications, but they're capable of switching low-level voltages and currents to give indications to PLCs and lamps. So now, I want to take one of these. Well, when it's not running, it'll be normally open. So let's get my green light, find the cable, and put it in the normally open contact. See what happens. There's my green. I think it should be normally open. So I'll slap it into my normally open. Like that. Now, my normally open lamp has got a switch. My normally open contact goes to a lamp. However, I'm sure you've already worked out there's no supply to the switch. So I'm going to take a supply off this supply, the permanent 24 volt supply, and feed the lamp. So off camera, I'll just disconnect that and I'll wire it through here. And I'll wire it through a couple more of these as well, so I can use any of these switches to produce 24 volts. So let me just do that, because obviously any switch needs a supply and it ain't got one. But I'm guessing if I put a supply in there, it'll power this cable that goes to my green lamp. Now, I've put a supply to that side of the switch and I took my green lamp out. You can see it's starting to look quite complicated, but remember, we've already got the 415 volt layer, we don't touch that. We don't touch the dole layer that controls the motor on and off, we're just adding stuff on another layer. This is not, I guess you're sat there thinking, well, how do I do this? Go and buy yourself a contactor and overload, some bits, cables, some lamps off eBay or something, but you can just as easily do this in a drawing. So don't worry that you haven't got all this gear, you can just do it in a drawing. But what I'm guessing now is, if I press go, I'm going to get a green light to tell me I'm running. And I have got a green light to tell me I'm running. And if I trip the contactor, because it's tripped, and because it's interlocked on the mechanical side of it, the trip lights come on, and the green light's run. So now, in various states of running, like now I've reset it, look, it's not started up again. Start it, it's started. Stop it, it's stopped. Start it and trip it, it's tripped. So what I'm going to do, because this is a remote pump, I'm going to add a little bit more indication. So obviously we've got a trip indication, we've got a running indication, and we've got a power indication. What I'd like to do is just add a stopped indication so that we know it's stopped. So I'm just going to take a feed to a normally open. Sorry, I'm going to take a feed to a normally closed, in this case. I'm going to take a lamp out the other switch. You maybe not get it, but I'm going to put the drawings up if this is on YouTube, and you can follow it through your finger. It's just a simple case of the lamps tell you where this is. And where this contactor is relates to whether the pump starts or not, or whether the pump runs or not. And we'll talk about how that's interlocked in a minute, but let me just put power to one of these, and we'll get that stop light running. So we've got full indication coming back. So now look, we've got even more wires, but what you'll notice is there's a red light on. In the case of my identification, that's to tell me, or the computer system, that the pump is not running, that no one is requesting the pump to run and there's no reason for it to be running. So I get the feeling that it's not running. If I press start, you'll see now I get a green that indicates it is running. Then, what else might you want to know? Well, what if it's tripped? Then you get a double positive, because now it's telling you, not only is it tripped, but obviously it's not running. If I do the reset, it'll just tell you it's not running. And if I press green, it'll tell you it's running. And all that time, the white light's on, so I know there's a 24 volt power supply. What if the power supply disappeared? Well, I'll tell you what happened. The whole thing had just cut off and I'd know there was no power. And when I reset the power, it'd go into the stop position and I can start it again. And it's not that complicated wiring this in, although it can look like it. It's a very simple collection of circuits. That's it. That's your indication layer. Your 415, your controller indication layer, yeah? All it is mechanical switches. It's when the contact pulls in, it pulls a contact. A contact can be normally open or normally closed. And you pick the correct one to light up the lamp. Everything you see that's like the auxiliaries on top of this overload, or these contact auxiliary blocks, is just a switch. Normally open or normally closed. And if you select them in the right order or the right type, you can make it show you things whether you're a computer or a human. As well as that, something else to grasp is, you could take it through one contact on one contactor, then another contactor, then another contactor. So for example, if you want to have a light, say, are all three pumps running, and you had three contactors like this, you could go in with some power, through the next one, through the next one, and through the next one. The world is your oyster with normally open and normally closed, to be honest. So that's indication. There's a lot to go out there. Just remember, humans need indication of what's going off to enable us to run machines. But more than anything else, indication needs to go to PLC so PLCs can decide if it has told a motor to start, has the motor started? If it has told a contact to pull in, has the contact pulled in? And it can just as well do both. It's very easy to wire using the right contacts for a contactor to tell a PLC and the lamp to come on. It's that easy. So yeah, look back over it, look over the drawings, and you'll see the indication and feedback, which is the indication of a PLC, is used a lot in drawings. See you next time, dickhead.